Problem 3 is asking us to solve a 3-variable system of equations. The first thing I notice is that the z's cancel in the first two equations, so I'm going to start going with that. 2x minus 2y plus z equals 3. 3x plus y minus z equals 7. The z's eliminate. I get 5x minus y equals 10. I have an xy equation. I need another xy equation to solve for x and y. So the next thing I notice is that this equation, this third one, has not been used. I need to cancel out the same variable to z, and I can most easily do that with the second equation that has a negative z. In order to make that work, I need to multiply the second equation by 2. So if I do that, I get 6x plus 2y minus 2z equals 14. Bringing down that third equation, x minus 3y plus 2z equals 0. Z's cancel out. I get 7x minus y equals 14. So now I have these two equations that both have x and y, and I need to solve them. I notice that I have a negative y and a negative y. If one of them were a positive y, they would cancel. So I'm going to multiply this equation here by negative 1. That gives me negative 5x plus y equals negative 10. So when I pair that up with my other equation, 7x minus y equals 14, the y's cancel out. If I add these together, I get 2x equals 4, so x equals 2. To figure out y, I can back substitute this x into either of these equations. 7 times 2 minus y equals 14. 14 minus y equals 14. That tells me y has to equal 0. Now that I know x and y, I can back substitute into any one of my original equations. I'm going to pick this one. So that gives me, instead of x, 2 minus 3, subbing in 0 for y, plus 2z equals 0. 2 plus 2z equals 0. 2z equals negative 2. So z equals negative 1. As a coordinate triple, I get 2, 0, negative 1 as my solution.